Hello, and we are CeaseFire Private Limited. Today, we'll be presenting to you the efforts our team has engaged in over the past 2 months in the creation of a water deluge system to aid in forest fire management. To guide you through our presentation, we'll be discussing these following topics as we guide you through the facets of our engineering and management endeavors. Environmental degradation is a severe problem expedited by human disturbances. Climate change has led to an increase in wildfires that ravage forests annually, leading to deforestation and a loss of habitat. Settlements on the wildland-urban interface have an increased risk of infrastructure damage and displacement of its citizens in the event of a wildfire. For example, 2016 marked the largest wildfire to hit Fort McMurray, burning more than 500,000 hectares of land, displacing 60,000 people, disrupting oil sands production, and causing an estimated $3.6 billion in damages. The severity of these fires is predicted to increase in the coming years due to the compounding effects of climate change. The prevention of these catastrophes and the reduction of their intensity is of paramount concern for financial, environmental, and ethical reasons. Our team at CeaseFire has been working diligently to address this problem. Our solution is the design of a massive water deluge system to aid in forest fire suppression. Taking inspiration from the NASA deluge system as seen here, we have 3 designs called the central deluge system, the remote deluge system, and the commercial grade deluge system. The central deluge system's cast iron hydrant is connected to the main water line. The deluge system releases 2,650 liters of water per minute and reaches a height of 38.5 meters, hitting the forest canopy. The hydrant covers an area of 5,350 square meters. The remote deluge system is intended to be installed in critical locations to reduce the fire spread, such as mountain ridges and fire breaks. The system requires its own water storage unit and pump. The system dispels 630 liters per minute and reaches a height of 34.9 meters and covers an area of 4,400 meters squared. Lastly, some of our stakeholders wish to install their own systems in their backyards to protect their property from oncoming wildfires, effectively acting as a backyard irrigation system. All systems come equipped with an electronic sensing unit to detect smoke and temperature. The system will automatically deploy upon the detection of a forest fire. The central deluge system is expected to cost $9,900, just shy of the $10,000 threshold established through the project scope. The remote deluge system is predicted to cost $19,300, which is $700 under budget. And lastly, the commercial grade system for the average consumer is expected to cost around $1,250. Now, the central and remote deluge system's cost is not fixed and expected to fluctuate based upon the contracts and installation location. However, one should not be worried about the cost, as the intention is that this is seen as an investment to protect existing environment and infrastructure. Protecting from fire damages will pay for itself after a single use.
These are the main stakeholders of our project. 4 communities in the WI are at risk of catastrophic wildfires and in need of deluge system. Both Dr. Flanagan and Dr. Beverly have been wonderful resources throughout this project's lifespan. We build close contact with third-party regulators to ensure manual follows all rules and regulations. The needs and desires of the relevant stakeholders are compared to the existing project scope and available resources. We maintain contact with them weekly to make adjustments and improvements to the project with their inputs, requirements, and expectations.
The next section is work breakdown structure. Work breakdown structure is the process of subdividing project deliverables and work into smaller and more manageable components of what has to be delivered. The following figure shows the different components of a work breakdown structure. The first section deals with the project management, which is an umbrella covering all the different phases of a project. Moving on to the second section is the design, and it contains all the work components related to the designing and modeling of mechanical as well as electrical systems. The next component is manufacturing, followed by construction. In the construction phase, detailed instructions are provided for assembling the product on site. The next phase is the testing phase. This consists of all the work components associated with testing of the product. The final section is the operation and maintenance, and it consists details about the system operation along with troubleshooting guidelines for routine maintenance. The following WBS were developed for overall project activities and a detailed explanation of each work packages. This dictionary contains an elaborated explanation of all the work performed under each phase of the project. Developing a work breakdown structure is critical as it helps to make the planning consistent and provides a path for effective project execution.
I will talk about a few tools we use to implement quality management. The first tool is engaging continuously with stakeholders. An example of this is the addition of the consumer-grade Deluge system to satisfy individual needs in forest fire-prone areas. Failure to meet quality requirements can have serious negative consequences for project stakeholders. The second tool is PDCA. PDCA is the basis for continual improvement. In our case, we had weekly team meetings via Google Meets to serve as a medium to delegate tasks and provide updates. The third tool is management responsibility. Success requires the participation of all members. Our Gantt chart and work breakdown structure achieve that by dividing the project into more manageable tasks. The final tool is maintaining relationships with suppliers. We intend to work alongside local suppliers as a method to stimulate the local economy and promote small business. A mutual beneficial relationship enhances both the ability of CeaseFire Private Limited and its suppliers to create value for each other. There are two types of contracts we intend to implement for procurement management: firm fixed price contracts and fixed price incentive fee contracts. Firm fixed price contracts are used when the requirements are well defined and no significant changes to the scope are expected. Examples of this would be the PVC pipes from Lowe's and a generator from Home Depot. Fixed price incentive fee contracts are used when we intend to work with local businesses and manufacturers. This contract will be used for the custom-made fire hydrant for the fire deluge system and the steel pipes attached to the existing water lines.
Project risk management. Project risk management is the process of identifying, analyzing, and responding to any risk that arises over the life cycle of a project to help meeting project requirements. Risk management involves 4 major steps, which are risk identification, analysis, response, and monitor and control. In our project, we arrange risks in various categories. For risk analysis in our project, first qualitative analysis was performed in which probability and impact of risks were determined on the scale of low, medium, and high. After that, quantitative risk analysis performed using tornado chart for manufacturing, shipment, maintenance, quality, and design for our project. Last step in risk management is determining risk response, monitoring, and controlling them. Monitoring process ensures that each risk requiring response has an owner monitoring the responses.
We distributed work packages in this project evenly. We classified all project activities into 6 broad classes. The first class was the project management, which we assigned Nigel, and the reason for this was based on his work experience and his leadership potential. Next, we had somebody manage the design of the project, and based on my mechanical engineering background, I was assigned this responsibility. The project requires some construction, so we had somebody manage the construction and safety of the project, which was Abisha. To ensure high quality standard, we assigned Long to be the quality manager. We assigned Siddharth Kumar to be in charge of procurement of material and resources. Lastly but not the least, in charge of communications was Stu Chen.
The next section is project communication management. Communication management is essential because it ensures proper expectations are set and also maximizes the success of the project. The communication management can be broken down into 3 sections of planning, managing, and monitoring. Effectively executing these can result in meaningful exchange of information between the management and different stakeholders. The following table over here shows the different components of how the communication is organized, managed, and monitored. The table focuses on the communication within different teams of our organizations and explains how the team are exchanging information with each other. The table also provides information about how the team will use different platforms along with frequency of the communication. During the course of project, communication was also managed with external stakeholders such as experts, contractors, and different organizations. They provided on-demand information and some necessary deliverables such as modeling and 3D design reports. Overall, an effective communication management was performed based on shown information tables, and it was a key contributing factor for smooth and efficient functioning of our project.
In conclusion, we are confident that the 3 deluge systems designed by CeaseFire will be a useful addition to combating forest fires with the goal to protect the environment and people. Best of luck with your projects, the rest of the semester, and stay safe. Thank you for your engagement with our project. And by the way, you can become a stakeholder in our project by supporting us on Patreon and Kickstarter.